Hello, everyone. Welcome to the webinar. My name is Dinesh Mukherjee from Tridagonal.ai, and we are here today. We've gathered here today to talk about our partnership, Tridagonal.ai and Cognite. Our partnership to deliver how we combine our expertise in our respective domain to deliver optimization solutions for industrial companies for furnace and
Dinesh, I think you were breaking a little bit. I don't know if it's only for me. Sorry, guys.
Dinesh, I think
Can you hear me now?
Still issue. Yeah.
Yeah, I'm sorry. I'm on wired connection, and I'm not sure. Maybe something with the webinar host server. Sorry about that. What was the last thing you heard?
I can hear you now, Dinesh.
Yeah.
At least I can hear you now, Dinesh. The last thing we heard was you kicking off the webinar. At least the last thing I could hear was you kicking off the webinar.
Yeah.
I'm
You can start.
sorry.
No problem.
Yeah. Let me just exit and come back. I'm not sure what's happening. Definitely, it's not internet problem. Thank you. I'll be right back. You hear me now?
Yes, we can hear you, Dinesh.
Yes.
All right. Sorry about the technical trouble. Not sure what's happening. But Murphy's Law struck again. This is not the first time. Okay, you should be able to see my screen. And I will start again. Hey, Simone, can you do me a favor? Shelly doesn't have the link, so could you please just send her the link for the webinar?
Will do.
All right. Sorry about that, guys. Thank you again. I'll start from scratch. My name is Dinesh Mukherjee from Tridagonal.ai, and we are here together to discuss the power partnership between Tridagonal.ai and Cognite to deliver optimization solutions for furnace and energy systems and hydrogen network. We have a couple of demos to showcase here, and we will try to do justice to y'all's time in an hour, but I would like to put a disclaimer that we may run over a little bit. We have a lot of complex material to talk about it, and we wanted to get some useful information out to the world or to our listeners instead of just trying to wrap this webinar up in 1 hour. There will be Q&A, and please post your questions that we will answer. And if we cannot answer your questions today, despite us staying a little bit longer, then we will show that by email with a written answer. But we are always here. You can find us on LinkedIn, and you can go to our websites for Cognite as well as Tridagonal.ai for any questions and answers. Thank you. With that, audio good, everyone? Simone?
So far, so good. Yep.
Oh, all right, thank you. For today's agenda, we'll just go through introductions and we'll talk about how Cognite AI and data platform serves as a great foundation for industrial AI solutions. Just adding to that, we can't talk about a solution without talking about the challenges and problems and how the traditional tools may not be applicable, not all, but some of them may not be applicable in today's world. And plus, customers ask, in we both Cognite and Tridagonal.ai, we have worked with a lot of customers, so definitely we get a lot of customer feedback, and based on that, product is getting improved upon, plus services delivery is getting adjusted along the way. So we'll talk through this, and this information will be useful in operationalizing. That's the key. Operationalizing these solutions, which is the most difficult part of the whole AI journey. And some live demo, closing, and Q&A. With that, I will invite my esteemed colleagues here to introduce themselves. Simone?
Yes, good afternoon or good morning or good evening. If some of you is in Asia, then I'm Simone Casolo. I work for Cognite. I'm an industrial AI expert at Cognite. And in my job, I help large industrial customers, especially in the oil and gas and the energy business, to identify how their data and now how AI can be best leveraged to, for example, improve their production, so production optimization, but also optimize maintenance operation and improve asset integrity. And I work with the Tridiagonal in exactly bringing AI to the industry. Pradeep, maybe you want to say something about yourself?
Yes. Thank you, Simone. So I am Pradeep Shahu. I'm leading a delivery team in Tridagonal, which is responsible for providing industrial AI solutions for refinery, petchem, and upstream and chemical businesses. I come with 15 years of operational background from the refinery. My expertise lies in integration of the process operation optimization and AI-driven optimization solutions. I work for converting the complex operational challenges into the scalable, meaningful, and data-driven solutions that have the measurable outcomes or performance and reliability improvement for the industry. And most of the focus is building on the practical and operator-friendly solutions that integrate smoothly in their workflow. So that's all about me. Back to Dinesh.
Thank you, privileged gentlemen. My name is Dinesh Mukher. I'm the global practice head for Cognite services at Tridagonal.ai. And I will, a little bit about myself. I'm a Cognite technology expert. And here at Tridiagonal, we help our industrial customers reap benefits from their industrial AI solutions and deploying their and operationalizing AI solutions in their complex operating environment. And the key is without compromising the operational stability. As you know, plant needs to be running, producing. So that's where it's important, the part to not disrupt the existing workflows and keep the existing system up and running. And how we bring in the AI-based solution in the picture. With that, we go to the next section.
Yeah, the next section is really like about setting the foundation and just to introduce a little bit what do we do and how we solve these issues, because we really experience that we are in the middle of an AI rush. And you hear a lot, or you can hear a lot about AI implementations, and most of these discussion focus really on the business and the business results. But there is still very little material out there on how all of these results are achieved, and what are the struggles and the hurdles that one can encounter along the path. So for us at Cognite, our experience is that industrial AI is actually much more difficult than what people believe normally. The data is very much scattered across different data sources. Also because typically our customers have been through a digitalization journey for a while. So there have been multiple initiatives and solutions and systems that tend to silo data and really to segregate them rather than bring them together. So it's typically difficult to QA and QC the data. And because of that, all the, first it was ML, now it's AI models that are created on top of this data tend to have different degrees of success. There's a lot of data that is not really leveraged, but it's also very difficult to scale. Especially when scaling is not really embedded from the very beginning into the design of these solutions. So what Cognite does with the help of Tridiagonal is, of course, first of all, providing easy access to complicated data. So Dinesh, maybe can you explain a little bit how Cognite Data Fusion was the core product of Cognite, can really act as a foundation for industrial AI, and how can this be useful to build AI applications on top of it?
Good question, and hard question right off the bat. Thank you, Simone. So I represent technology side of things in this group, and we have our Dr. Simone Casolo and Pradeep Shah. They're the domain experts. So to balance out for building on the technology side. To answer to your question will be number one, easy access to complex data. I know this is a great tagline, but very powerful. In 5 words, it proves. I work with Cognite Technologies, setting up customers with with the data platform, and I have personally seen that how IT, OT, and ET data is all integrated in a way that's easy to consume for the end users. With the data platform, pretty much I would say I will make a very profound statement that the power shifted from technology to business, because now once data is there, you have a whole lot. You don't need to you don't need to ask anyone to program it for you. You can create your own dashboard. You have all the information about the data in the form of metadata lineage available in the data platform. So that's why easy access to complex data. There's many reasons, but we don't have time to go through all of that. But sorry. My second favorite is industrial knowledge graph. Essentially, it's around ISO 14224 and other standards. Those are those out-of-the-box models allow you to quickly ramp up your data models in accordance with industry standards. And number three, with all the data being there, and with the AI up and coming AI solutions and innovations, LLMs will be, and that's a again profound statement that I heard from someone, that LLMs will be the main interface to enterprise data. So we just when we were feeling that, hey, we need LLM capabilities in Cognite AI and data platform, with Atlas AI's introduction last year, the GA was in September. Definitely that has added the missing dimension, so that now you have the data available at fingertips, and then being able to interact through Atlas AI, the workbench that has access to AI-ready access to IT, ET, and OT data. A little bit adding to what I'm saying, that this is the data journey from data acquisition to all the way as to how it is utilized, how it's put to use. On the data integration front, all the out-of-the-box connectors, we use them to quickly connect to the source systems. And this compounded with the contextualization, I'm sure if you are here, then you understand what contextualization means. And essentially this term was coined by the Cognite team. Adding heft or adding proper semantic layer to the data is all about contextualization. And then that leads to creating an industrial knowledge graph. That's where information turns into knowledge. That's the key. We all have a raw data available, but being able to harness that for useful purposes, namely for AI solutions, that's where industrial knowledge graph is very powerful. And on the end user side, the set of SDKs and REST APIs and Atlas AI, that all of them make it enables you to easily get value out of your data that is residing. It's siloed at the source, but it's all brought together. Lastly, on process-aware knowledge graph, and this is where we at Tridagonal.ai, we bring our domain expertise to take the solutions or technologies or tools in Cognite AI and data platform to next level. Essentially, traditionally, it's all the asset hierarchy or knowledge graphs are based on PNID. Interrelations reflected in PNIDs, but we take it to the next level using Atlas AI as the tool to create value chain based contextualization, where we are bringing other elements of the entire ecosystem that supports the process, industrial process, to put together a next level of industrial graph that we call process aware knowledge graph to that aids in the organizations adopt AI space solutions so many ways, enables process investigation and ontology, which we'll talk about this a little bit from our guests here. But now, Simone, question for you, because you are a domain expert, plus you're a data scientist. So how would you answer the same question? I would love to hear that.
Yeah, so I prepared a slide that you'll show now, Dinesh. It's really about a tiered approach. Like there is a layers of a pyramid, and if we start from the very bottom, we start from what you described as the data foundation, the data integration layer. If you could just skip exactly this slide. So we need, first of all, to make the data available. That's the first step. Any agent would rely on the data, and this is really where Cognite Data Fusion excels and starts to work. It's really bringing all the data together. And mind that this does not need to be the time series and your historian, your DCS, but could be SAP data, so your ERP, for example. It could be market data, it could be supply chain, it could be weather data, it could be whatever kind of data. Just putting it together, harmonizing this, doing QA, QC. It's not just about dumping all the data in a data lake, which is an approach we have seen before in the industry, but it's about to clean, to transform, and to build a single source of truth. This is really like the fundamentals, the base of the pyramid. So the second layer is what you were talking about before, this knowledge graph. So which is also, in other words, is the data modeling. So imagine being an agent, like having one data point that is 20.14 or whatever. It's just a number. But then now we transform these, that is just a number, to an entry in a knowledge graph that would be 20 point something bar, which is a pressure. There is a reading that comes from a sensor, that is part of a pump, that it's part of a bigger industrial equipment, that is upstream of a stripper and downstream of a separator, for example. We are building relationships. We are building a process understanding for then the solutions to access and to leverage. So This semantic relationship and semantic understanding is also known as an ontology, and it's really what gives the meaning to the data, the interpretation and the context, the contextualization to the data. Then we have the domain workflow layer. This is a little bit more of the technical part. It's like where the machine learning, where the calculation. So now all this data is there, is available. Maybe you want to use it to produce other data. Maybe you have what-if scenarios. Maybe you're trying to do troubleshooting. Maybe you want to run physical simulations. And then here you plug in, for example, your HYSYS, your Prosper, your GAP, your Olga, your simulators to generate and augment even more the data. And then, all on top of all of this, now with this agentic AI revolution that we are witnessing right now, we have this intelligent copilot kind of layer. So the LLMs, the large language model, that is really leveraging everything that is built in the previous layers, and this is now really grounded in the knowledge graph that is below. So the LLM doesn't have, it will not hallucinate, because it will go and fetch a specific data entry that is part of the knowledge graph, knowing exactly what he's talking about. So when an engineer is asking for a recommendation to the AI, the agent is just not looking at the internet or a text, but really invokes the relevant domain workflow. So then it might trigger a simulation, might trigger a calculation, and then interprets this based on the actual reality of the plant. Is the calculation really reflecting the reality of my process, or there is a gap? Why is there a gap? And so on. So we're moving from a chatbot to really an industrial agent that can be trusted and then produce some actionable insights in here.
Answer.
Now,
thank you for elaborating.
Yeah, I would like to really give the word to the mic to Pradeep now, because Pradeep, you have the industry perspective, and so I would like to hear a little bit from you, like what are the key challenges actually that the industry, that our customer is facing today. So how can all of the things that me and Dinesh mentioned now can be used at the service of the industry and the industrial problem?
Yeah, I would say that is the most important question that we need to ask when we are building any digital solution for the industry. And yes, the industrial optimization is inherently complex. Why it is so? Because of the interconnectivity between different segments, different sections, different units. A lot of dependencies are there. When we talk about interconnectedness, it is because the different sites have different targets, different constraints. The plants are operating in different scenarios and different strategies. For example, let's say if we talk about FCC and we want to optimize the yield, we have the margin in the reactor inlet temperature, reactor outlet temperature, but sometime our fractionation section or the compressor is limiting. So we cannot take that action. Sometime the constraint can be business side constraint also, that we don't want to produce more cat gas, we want to produce more gas oil. Sometime it is related to some equipments, and sometime it is related to certain safety aspects also, that our CO2, CO emission that is going on higher side, so we cannot take that action. So the important thing is to understand that site-specific dynamics, wherein the model which worked at one part of the world cannot be directly replicated to other. So that intricacies are there. There are different operating regimes. Plants are operating at a higher throughput or lower throughput, or different operating zones. Like let's say, take an example of hydrocracker. It may be in SOR condition or EOR condition. It may be in the overcracking regimes, wherein every change in the reactor temperature or every change in the feed will not have the same yield of the product. So all that intricacies make the problem very, very complex. Even when we talk about certain other units like a delayed coker unit or ethylene cracker units, so they have their own problems of the furnace run length, where the inherent processes are cooking inside the furnace tubes. And that is one of the optimization problem that they would like to solve. When we come to the crude distillation unit, there they have the different issues to deal with. They have the different type of crudes that are coming day in day out, and they have to tackle that change in the feed scenarios. So every plant and every site, they have their own constraints and targets for which solution has to be built, and that is why that strong domain dependence is there. And understanding the problem, understanding the dynamics is very, very important. Similar thing goes with the maintenance practices also. uh, we can identify the anomaly detection, but it depends a lot on in which regime or which condition the plant is operating. At different operating conditions, the equipments will have different behavior, the parameter will have different ranges. So a straightforward application of statistics or ML modeling, anomaly detections, or AI tools will not implement certain solution, will not yield certain result. It has to be backed by strong domain insight. And then as we go ahead, now the customers are looking into the more advanced solutions. They're not just asking about what has happened, they're also asking that once you identify that, we need to do the reasoning of that also, that why it has happened. We need to go to the root cause. We also need to provide the actionable intelligence. So that workflow level optimization is very, very important in today's world, where everybody is constrained uh, to produce the result and produce the value. So that is where I feel that a lot of data that exists in a structured and unstructured format, but it is very highly underutilized, because to get the real value out of that data, it is important to understand that, decode that, understand the knowledge behind that, and then it can be integrated into the particular solution, particular platform, to generate certain valuable or meaningful solution. So now I would like to ask Simone, you about why the different tools that are already exist in the model, the traditional tools. We have a range of tools for different solutions. So what are the shortcomings and why they fail to deliver in this complex industrial optimization scenario?
Yeah, thank you, Pradeep. So yeah, there is a lot of pitfalls in developing AI, and I list some of these in this slide. But first of all, I want to talk about poor scalability. We have seen many times in the industry that what does a data scientist do? It takes his data and a little bit in a vacuum starts to train his model and focus on the accuracy and so on, doing feature engineering, and we know how it goes. This works very well at the single asset level in the isolation of the one data set, but it's not the way one built to scale. And this is really what we are trying to do at Cognite, that we really want to build from day one with a multi-asset, highly scalable architecture in mind. So we need to start first, as we said before, with the ontology, with having a very standardized and a very tailor-made, sounds a little bit an oxymoron here, but it's industrial standards for example, subsurface and oil and gas. It could be what's known as OSDU, or maybe if the application is more geared towards maintenance, would be ISO 14224, or SHIFOS. Maybe in manufacturing is going to be ISO 95 or ISO 98. But really starting with a very solid data foundation that it's independent from the details of the single equipment, and then therefore is portable. It's portable across the whole industry and the whole value chain. So really don't think about the single asset level, but really go and think scaling from the very beginning. The second big issue that we see is really this high engineering and maintenance cost that these models would incur into, because if everything is very stiff, like if your knowledge graph is not, for example, maintained by an AI, so every time the topology of your process changes, every time you have a trip into a sensor, or every time this data source is not available anymore, then you need to go and do something to your data science model. You need to put your hands on your data model, on your data science model. And again, basically you're moving, maybe you have a model that you use to optimize maintenance, and now you're moving your maintenance cost into maintaining the software rather than maintaining the hardware, which makes very little sense. And, finally, we have also this data gap. There is an integration in the industrial context. As I was saying before, there is a lot of heterogeneity of assets. So an asset that was built in the 90s has challenges and structure and topology that is very different from one that has been built in more modern times, and so on. So there is, again, the portability as an issue here. But what I really want to highlight in here is that whatever you build in AI, it has to be trusted. So if your users, if your engineers use your AI tool and the answer is not particularly transparent or not particularly accurate, they will probably stop using it very quickly. So it's very important that you have a zero noise mentality. So you want to almost have a deterministic response from your agents, and something that is very transparent and verifiable. So in a way, you want to limit hallucinations as much as possible. And this is, again, the advantage of having something built on an ontology, because when the LLM is giving you an answer that maybe invokes some simulations, invokes some data, then the LLM can go and fetch this data and show you, this is why I'm telling you that this is the situation. This is why I'm telling you that the most likely root cause for a problem in this process is this and that, because can actually go and fetch the data and present them. And this is, in our experience, the best way to build trust and to build, stickiness and a robust usage of solutions in AI. So Dinesh, I send it back to you now. It's this is really the Cognite experience when it comes to AI tools in at least in these last 6 to 12 months in the industry.
Thank you, gentlemen, both of you. Definitely, this is where all this information is helpful in operationalizing. It's one thing you, like you said, develop the solution, but this definitely allows you to think it through as to how it will go to production, how it will be sustained. Thank you. Thanks for your insights. For moving to the next section, what we have been working with a lot of customers, both Cognite and Tridagonal.ai for years. So love to hear Simone, for what's your experience been around customers' needs or all these problems. How do they envision that can be solved?
Yeah, so going back a little bit to what I just said, there is definitely a lot of focus on explainability. So again, related to the trust and not being black boxed. Scaling and enterprise deployment, so especially for large companies, and of course, again, the accuracy of the models. So I just want to focus a little bit on the limitations, because if right now some of you is thinking about agentic AI and LLMs, there are several approaches, more traditional approaches that one might use in industrial AI projects. So a generic LLM approach, which would mean basically just taking a GPT or Gemini or an LLM from the market without any connection to the data, that would necessarily lead to hallucination, as we discussed earlier. Okay, so I think you all understand that this is not a very reliable way to approach an AI problem. Some other people recommend to train an LLM or an SLM, like a small language model, on your data. So sort of like very tailor-made to your enterprise. And you build a local LLM that will know everything about your data and your company. And we are not particularly fond of this option. We use it sometimes, but we believe that this is really limiting, because with a knowledge graph that can change and evolve and adapt to whatever is happening in your organization, changes in your process, changes in, especially if you have economic data and supply chain data, you want something that is more flexible than a locally trained large language model. So we really advocate to go into in a different approach, which is what we use with our Atlas AI platform, which is basically leveraging the knowledge graph, but orchestrating with LLMs. So what does it mean? So the LLM becomes an orchestrator that can go get query data, explore the data from all your system, but then can call machine learning simulations, for example, can call your simulators, and then can analyze with a critical eye all of these pieces of information. So as I was mentioning before, if you want to do root cause analysis, you're looking at your current data, or actually the LLM is looking at your current data and comparing it with the past. Is it the same? Is it any different? And then maybe running multiple simulations and say, okay, let's have a simulation, maybe if the suction pressure of this compressor went down, what happened if the bearing had a problem, and so on. So running scenarios and comparing, and then coming with the recommendation that, because this scenario looks very similar to your actual production, I believe that this is, for example, a bearing. And this applies also to production optimization, to supply chain optimization. But this is really because you leverage completely the flexibility of your agent, or your multi-agent in some case, leveraging the ontology, leveraging all the tools that you have available. And this, the framework to build these agents and these multi-agents is what we call Atlas AI. It's one of the agentic frameworks that we have available on CDF. So this really, in a nutshell, is like how Cognite contributes to solve this problem. But then, of course, there is a lot of domain knowledge that goes into this, and we cannot have all the domain knowledge of the world. We rely on our partners, we rely on Tridiagonal, and this is why I really want now to pass the mic to Pradeep and ask how is Tridiagonal solving these industrial problems? What is the approach that you guys take at Tridiagonal to deploy industrial AI at scale?
All right. Pradeep, we can't hear you.
Yeah, sorry.
No worries.
Yeah.
Okay. Good now.
Right. So as we have now the data platform available, the data augmentation there. So the important thing is what Tridiagonal can do is we can build a meaningful solution, which is really a value-driven solution for the industry. And how we can do that? Because we have the deep domain expertise of different industry. We have the global experts who worked in a different section of the industry at a different time, and they understand about the real world problem, and we can drive that solution, that the how part of that once we have that industrial challenge, how we can make our journey from identifying problem to delivering the real solution for that. We have the technological breadth also, which comes in the IT OT integration part, data ops or simulation part. We can stitch very well the symbolic AI, ML, physics augmented AI, and agentic AI. So different part of AIs have a different application depending on what is the problem statement, and we can stitch that together so that we are not just providing a platform or solution, but we are providing the purpose-built operating system which can solve the real world problem for the process industries. We also provide that deep domain network intelligence because of the interconnectivity that's there in the industry between different sections and different units. So we also take care of that to make the solution very meaningful and orchestrable for the different sections. We have the ready-built frameworks utilizing all the platform intelligence and the different part of AIs, so that we can build the solution and we can drive the journey of value generation very fast. And that's why we have that the delivery models ready for the different industries, wherein we can help as a scale partner for Cognite. So I would say we are the one who can drive the journey end to end, right from conceptualizing the problem, identifying the issues, doing the blueprinting, building the roadmap for the program level engagement, and then operationalizing different use cases, right from pilot to the scalable limit. And we can support in value generation and the sustainment, and we have the total end-to-end ownership of this total roadmap or total journey. That is where we build that uh, confidence with the customer. So that's what we add with respect to Cognite as a tridiagonal. So yeah, Simone, it's up back to you.
Yeah, I appreciate Pradeep, like you showing all these steps. I think that so far we have been really talking a lot about all of this, what you should and what you shouldn't do. I think it's now time to show something a little bit more concrete. So I believe you have a couple of demos to show, and I just want to highlight that these demos have been developed in CDF. We actually typically you deploy on a SaaS infrastructure, you deploy your UI, you deploy your models and so on. These models, of course, have been developed within CDF. There is an environment for prototyping and an environment for dashboarding. So it's a little bit more of this quick turnaround and experiment. So this is why you'll see something on a little bit simplified UI, but this is for you to understand how you can use, even just leveraging only the built-in and the native components of CDF, how can you spin up fairly quickly a scalable AI model with an agent to which you can ask questions, and that solves a concrete industrial use case. So I think the first one you have available, Pradeep, it's about a furnace, right? Maybe you want to share screen?
Yeah.
Oh,
Yes.
before while you're doing this, sharing your screen, if I may fill in
Sure.
a little bit here for just adding to what Simone you mentioned. What we like is with the built-in tools, it's a low-code solutions. It's being able to, instead of worrying about, it's my favorite part, worrying about how will I deploy, how will I operationalize it, how will I secure it, all of those challenges we don't have to worry about. It's all about building the solutions. So that's what using the data platform and combined with Atlas AI, how we are leveraging all the capabilities in the platform. Back to you, Pradeep.
Yeah. So I have two demonstration to show you here. So whatever we were talking with respect to the partnership or with respect to the domain intelligence. So now we will have the practical session for that also. So just let me share my screen.
Yep, please.
Yeah. So I hope my screen is visible.
Not yet. Yep, we're good now.
All right. So the first case that I'm going to talk about is about the furnace length optimization in ethylene cracker unit. So as we know that ethylene cracker is the furnace is operating at very high severity, and there is an inherent tendency of coking that is happening in the furnace coils, and that is going to reduce the run length of the coil. And the run length of the furnace coils is a very important parameter for the operation of the ethylene cracker. So what we are doing here is we are using the CPR, the coil pressure ratio as an indicator, and we are predicting that so that we can predict the run length of the furnace, and then we can have that intelligent insight for the operation team. So whether we are running at a higher severity or lower severity, because let's say if we are running at a lower severity, so we have that opportunity to increase the feed, opportunity to increase the severity, so that the yield can be maximized and that margin can be utilized. But let's say if we are running at a very high severity, so that time our run length of the furnace that is at stake. So we need to ensure that we have that optimal run length and do not end in the unplanned shutdown. So that is what we have built, and I will quickly go through the demo part of that. Yeah. So this is a CDF environment, and this is the dashboard for this particular use case. Here, the first indication that we see here is the current coil pressure ratio. And for those who don't know about the coil pressure ratio, it is the ratio of the individual coil pressure with respect to the total feed pressure, which indicate the severity of coking that's happening as the coking increases. So the CPR value tend to increase. And at particular optimal range between zero 0.8 to zero 0.9, they have to take certain necessary action to again revive that coil so that it again go to SOR condition. So what we are doing here is we are predicting the next 1 day forecast for the CPR and next 7 day forecast also. So this is where the operation team, they can get the insight that how their severity is running, what is the operation severity they have, and if they have to plan certain things, or if they have to plan certain feed increase, feed changes, or monthly plan they have as per their business plan, so they can adjust their parameter accordingly. In this dashboard, we are also showcasing certain trends or graphs, which are the input for predicting that CPR value, which is a hydrocarbon feed flow, the dilution steam flow, tube metal temperature, and coil outlet temperature. So these are some of the parameters which affect the forecasting for that CPR value. And this is how the CPR will look like. At certain point, it will peak. And at that point, when the site takes certain action to revive the coil, so it will again lower at initial value, which is around 0.5. So you can assume that from 0.5 to 0.8, this is a operational length for the furnace, which sometime between 3 to 4 months of the time, the operation team get in between that two values. So what you see in the blue color is the historical graph of the CPR, and we are at this junction. The purple line is the forecast of the CPR based on the operating conditions and based on how we have operated in this regime. So that is the forecast that we are giving for next 7 days, how things are going to happen. And then we also have utilized the Atlas AI, which the Dinesh and Simone was talking about. So here we are adding that intelligence also, wherein we are not just showcasing the CPR value, the trends, but you can also query about it. You have the what if agents and you have the CPR RC agent. In what if agent, you can ask about what change can happen if we do certain changes into certain parameters. So let us ask that what will be the change in CPR forecast for 7 days if the coil outlet temperature is changed to, let's say, 810. Currently, it is operating at around 824. So this is a one of the very powerful tool wherein we can analyze that if we change certain parameters, whether it's a coil outlet temperature or feed, so how the dynamics will change and what will be the outcome of that. So that kind of intelligence once the operation team is having, so it can take that intelligent decision about planning their strategy for next 7 days or 10 days, and accordingly that can be optimized. So as you see here, the 7-day forecast impact will be provided, and what are the inputs that we are using and the change in the input, that is also will be shown here. So these are certain inputs that are used for the prediction of that value. And what we have changed is we have changed the coil outlet pressure, coil outlet temperature, from 824 to 810. So accordingly, the change in the value of the CPR, it will project, and based on that, that intelligent decision can be taken that if we have to take certain action with respect to certain values, so what we can do with respect to parameter. Then there are yeah. So I will go to the one another section wherein we have this the RC agent also, that when we query certain things, that if we want to understand certain parameters, yeah, this one, right. So if you want to analyze certain things with respect to CPR value, so if we have to analyze last 7 days values, that how our trend for the CPR has been and what are the reasons behind that. So that also can be analyzed through this. So as you see here, it is showcasing the low CPR rise for last 7 days. And there are different reasons also that are listed here, the possible scenarios that we are underloading the furnace, and that is leading to the increased run length of the furnace. And that way we can have certain conclusion that this is a condition where we can utilize maybe to increase the feed or increase the severity, which can yield certain results in terms of more products or the better product quality. So that decision can be taken by the site team. So this was the one demo, and then I will go back into about the second demo. It is about the hydrogen plant, the steam methane reformer. So when we talk about the steam methane reformer, so one parameter is very crucial over there, which is a C1 slip, the methane slip into the hydrogen. So every site has certain range of tolerance for the methane slip, and based on that, that decision of optimization can be taken. So let's say the methane slip is going high, so that time they have to increase the S by C ratio, which is steam to carbon ratio, and the reactor outlet temperature to increase the severity to reduce the methane slippage, and vice versa. When it is at the higher side, at the lower side, so they can relax on this situation, because the steam methane reformer is one of the most energy intensive unit for any particular industry. So there's always chance of saving energy with respect to the steam saving or with respect to the fuel saving if you optimize the ROT. So I will go back to demo part of that. So as we see here, this is a SMR optimization dashboard wherein we are able to see the current value of predicted methane slippage, which is 2.8%, and the steam to carbon ratio and reformer outlet temperature. So at present it is 822 and steam to carbon ratio is 3.2. We also get to know about the current condition of the plant, and it will also have certain recommendation listed here if we are deviating through certain parameters, As of now, we see that there is no recommendation because we are operating within the range, and it is a good operating condition as it is showcasing over here. We also have the indication of the feed and the pressure of the hydrogen here. At the bottom, we have the different section wherein we can check whether if we have to change this parameter. Let's say it is running at 2.8 percent of the methane slippage. So what will happen if we change that, and what action need to be taken for that? So I will just in the interest of time, I'll switch to the tab. Yeah. So here what I'm showcasing is about the change that is we can see. So let's say currently it was 2.8% methane slippage, and we are intending to make it 2.6. We want to lower it. So we have to increase the severity. So when we do the questioning on this, so because of the Atlas AI intelligence, we get all that recommendation around that we need to increase the ROT by 1.5 degrees Celsius, and we need to increase S by C ratio by 0.05. And that is when we will be able to attain the desired result, which is lowering the predicted methane slippage. Not only just this, we also have designed here the what if scenarios with respect to different strategy. That here it is recommending to change both ROT and S by C ratio. But let's say if you want to play with only one parameter, so what need to be done? So let's say if we increase the ROT by 3 degree, so S by C ratio will decrease up to 2.59 if we don't change any S by C ratio, and vice versa will happen when we decrease the ROT, so it will go up. And when we don't change the ROT from the current value, we just play with the S by C ratio. So that time also what will happen to predict the slippage, that is also listed over here. If we increase the S by C ratio, it will decrease the slippage, and if it decrease that, it will increase the slippage, which is very well in the direction of our domain intelligence also. And it also captures all that non-linearity associated with the complex relationship between S by C ratio and the ROT. And that way, that tool is helpful to give that kind of intelligence for the operational changes day in day out that the plant want to do, and that way it can bring a lot of value on the table. So going back, so these were some of the demonstration with respect to what we are doing that I want to show. We'll be happy to walk you through more also, but because of the time constraint, we are just kept these two, and you can always contact us to see more about that.
Thank you,
So
Pradeep.
now up to Dinesh for the key takeaway. Yeah.
Sorry, I jumped. Thank you, Pradeep. Simone, any comment on what Pradeep just showed?
No, I think that, these of course are two demos like that could fit the timing and the limited background. That sometimes these things can get quite technical. So I again encourage all of you that have a specific focus to contact us. I have answered in the meantime into to one of the questions that appeared in the chat, and here was asking for more references, and there is a link in there that I invite you to click and read with some reference use cases from our experience.
Thank you, sir. Pradeep, could you please go to the next slide here, the last slide? We will open this up for question Q&A. But before, so now hopefully you please understand why we asked for a little bit extra time, because the content is thick, and rushing through it just for the sake of rushing through it, and that would have not delivered any value. That would have not made you happy. So we wanted to make sure we do justice with your time. To conclude, we, if you recall, the title of the webinar was the power of the power of partnership. So just to put that, that was chosen deliberately for as to how Cognite and Tridiagonal assist in maturity, AI maturity journey. And what we see here on the graph or on the slide is one of the great representation for how you progress along the way and increase the value. For since today we showed up to Gen AI, which was you saw interactive conversation that Pradeep did in a live demo, and being able to analyze various situations based on the dynamic conditions. That enables a lot of that that's a great stepstone for verifiable AI. That's what Simone was saying. That's a verifiable AI. Once the results or recommendations are trusted, the next step is agentic AI, which is autonomous. And if I say that today in industrial AI setting, if autonomous, if I say customers are doing, then if I make that claim, you will laugh at me because it has to be validated, verified, trusted, and explained. And that's we hope to showcase that in our next webinar. Right now, we are all Cognite experts like Simone and Pradeep, domain experts, and our AI ML engineers. We are trying to see how we put guardrails on those solutions to enable human-led and AI-operated solutions. With that, I'll go through the questions here, and I'll ask my colleagues here to help me with some questions because I can't answer all the questions. So for Simone and Pradeep, if you can go to the questions, and I'll let you read, but I'll read this here so everyone knows what questions we are answering here.
Yeah, I can maybe take
Number
number. Yeah, go ahead for the first one. I'll answer it. I have actually already.
You go ahead with Sarah's. Is everyone able to see these questions? I'm not sure.
I think so.
Okay, all right. So please go ahead answer Sarah's question, Simone.
Sarah, okay. Sarah says, I like the task-specific agent approach for interacting with the CPR forecast. How do you validate the responses? How would the end user validate responser when using these insights in the work process? I think this is more for Pradeep than for me, to be honest, but this very well resonates with what I was saying before about being not black boxy. Please, Pradeep,
but
how does you validate the CPR forecast?
I'm sorry. I want you to tag team, at least if I'm sure the question applies in all scenarios. So if you were in the solution that you developed, if you can give your insight, definitely that'll be beneficial, and then Pradeep will answer that too. Please go ahead, Simone.
Yeah, okay. So when it comes to a forecast, I mean, of course, you cannot validate with like the current the current data. So what typically you can use for validate the forecast, you can do it back in time, basically like ask the agent to do the same, but a day ago or 2 days ago, and then validate that result with what has actually happened. In general, another approach that you could use is looking at the reasoning, like asking the agent, show me why you say that the forecast is going to be growing or falling and so on. And typically what the agent should do is to show you the trail of thoughts. Typically there is some calculation that it's used. If there is could be some simple machine learning like an ARIMA or whatever, or it could be an actual simulation. If there is an actual simulation, then the agent should be able to show you what is the input of the simulation, what is the output of the simulation, and then in a way the answer would be, I believe this is going to be plus 10% because this is based on a simulation done with these parameters, and probably there will be also some other data that would support this. But you can always ask the agent to explain what brought the agent to give this kind of answer, and this is typically it's very transparent. I don't know, Pradeep, if you want to add anything for the specific of the CPR forecast. This is a little bit more of a generic answer, of course.
Yeah. So the main important thing is validating that through the domain knowledge. So whatever the prediction that model is producing, so we have that the test environment for the historical data with which we are training that model. So we set apart some data and we thoroughly validate that model in a different operating regime, that when the load was low or when we are operating at a different severity. So for all that section, the model should be able to predict well. And when it is a forecasting model, so we also make sure to use certain time switches during validating and during on the training model, because as Simone said, because we are predicting the future, so we need to be sure that whatever we are predicting should be in directionally good, and accuracy also should be high. So that is why we use that time switching model for that. The most important thing is that after that also it should obey certain constraints with respect to the mass balance or the physics based rules. It should not give certain answers which is away from that. So that layer of uh, physics layer of intelligence we also add during the modeling, so that whatever answers that we are getting, that is within the acceptable range. So there's a lot of validation. I'm just explaining at a high level because there are data scientists and domain people who are working with these models to make it robust.
Just for disclaimer, Sarah is she's my former colleague, and she's the first data scientist who
Oh,
worked with me and taught me a lot. So hopefully, Sarah, we answered your question, but definitely we will. As you know, this is a very trick question or complicated answer to it. So I'll be glad to talk to you. Thanks for joining
yeah.
this session.
Glad to have you here in the webinar.
Maybe I can take the question from Satishvar. So there is a question about what are the challenges in building and maintaining ontologies, guidelines for on leveraging existing standards. Very complicated question. I can tell you that, yeah, there are definitely guidelines. DNV, it's one of the institutions that are actually releasing guidelines on how to do this. The short answer is that there is definitely these change a little bit between domain and domain. The new frontier, as I'm actually writing an article about this, is using LLMs to maintain and populate ontologies. This is the frontier of ontology work in the industry, and it's something that we are working actively on in these days. Just again, super quickly going through the questionnaire here. I see there is another question. Maybe is for Pradeep from Subramanyam.
Yes, yes. So the question is about who are our typical customers where the solutions are provided? Are they licensors or the operating companies? So it is mostly the process manufacturing companies which are working for production of different chemicals or petroleum products, or some upstream companies wherein they have the exploration field. So they are our major customers. And apart from that, we are also working for the workflow automation projects. So wherein certain design companies or certain technologies solution companies, they are also facing certain challenges with respect to managing the documents, managing the lot of data sheets, manuals, and because all that knowledge repositories which they have already, for the any new set of creation of that documentation, they need to dive in and they need to use that intelligently. So that kind of problems also we are solving. So that totally depend on the problem, because we work on both the structured and unstructured data. Mostly the structured data comes from the operating plan, but this kind of companies where certain unstructured data are also there, so we also sometimes work with them.
Thank you. I'll take the next one. If any follow-up questions, Subramaniam, please post it here. But to answer Alan's question, is is there a means of training the models under the hood if there are incorrect predictions? How we make a correction? The best way to answer that question is for, as you know, this is industrial AI solutions have to give you deterministic answers. That means you ask the same question, it gives you the correct answer, and every time, because you can't take risk. So in that spirit, LLMs in Atlas AI, Agentic AI Workbench, they are powered or they're supported by your own particular ML models. And that's where domain experts come into the play. And for those models are powering the answer to certain queries, and those there's sustenance program around those models that you put into place that involves periodically checking the veracity of those we develop dashboards around it using Streamlit so that end users can using the test data and all of those standard mechanisms to validate the ML model as time progresses, and essentially being able to supply the parameter. Sometimes it needs a code adjustment. I'll be honest in saying sometimes you need to do the code adjustments. This is a ongoing maintenance or sustainment of ML model is indeed a task that continues.
Yeah.
Please let me know if any follow-up questions. Next one,
So
Simone,
Dinesh,
you want to take a shot at it?
yeah, Dinesh,
Yes, go ahead.
just want to add to the previous question of about incorrect prediction and training methodology. So to be honest, when we talk about any model development or anything, it is not just like taking data and using a tool to build any solution. This is an iterative process, and there itself the domain intelligence and that expertise of the model development with respect to different forms of AI, as we are talking about the symbolic AI, the causal AI, the agentic AI. So that experience counts. So that is where, as we talk about the Tridagonal and Cognite partnership, so that makes the difference to provide that the accuracy of prediction, the accuracy of model. And when we talk about the accuracy, so it is not just internally validated by us, any model that we deliver. So before actually it goes live or it goes into the production, we have the thorough validation with the customer also. And once they are satisfied and they have that all what if scenarios, they can run through that, they can play with that model, and after that only we have the deployment of the model.
Thank you. Before we go to the last question, just I like to add this. With the demos you saw, those demos were developed within a span of 1 month for initially, and then of course, then eventually they were deployed in customer environments. But bottom line is, for you bring the data, enterprise has the data, we don't control, but we bring our ML models. We've been doing ML modeling before ML models became the zeitgeist. So we physics enabled and all practical aspect realities are embedded, and that's where domain experts working. Our domain experts like Pradeep, they are also data scientists. So, and same thing, Simone is a data scientist at the same time oil and gas expert. So that having that blend of expertise allows us to develop models that are able to catch these problems up front. And I do want to share that was very insightful that in AI world, especially with generative AI, the best set of people who will get the benefit out of that are the experts, domain experts, because they can't. Number one, they know how to ask the right questions. Number two, they can validate. So if you get wrong answers, they are the first one to know how to validate and identify issues. So I'll leave it there, and we go to the last question. Simone, if you can please repeat the question and take your first shot at, and we'll chime in if needed.
Yeah, so the question is, are AI models able to predict soiling handling plants like polymer plants where choking may cause deviation from actual expected outputs, and how the model handles these failures and upsets? So I'll be very quick in the answer. In theory, yes. This is the type of problems that our models and our AI can solve. Of course, we cannot just say a blanket yes statement over this because it all depends on the data, and without seeing the data, is very tough to be to give a clear answer. But in theory, this is the kind of problems that the AI that we develop is able to handle and solve. Yes.
Yeah.
Thank you, Pradeep. You want to add?
Yeah, sure. So right now in the industry with this refinery or petchem, so there are a lot of these challenges with respect to different plants like a delayed coker unit, which is also semi-solid kind of material handling where the coke formation is happening in the coke drum, and as you stated, the polymer plants. So there are different strategies for the different units. The most important thing is to understand the different inputs that lead to the coking, and the first effort will always be the protection from the clocking or the choking, and that is where the value addition, the first value addition will come. So our first effort will be identifying the operating scenarios and recommending the best scenarios wherein we don't have that kind of upsets. Of course there is a gradual change that is happening, gradual degradation, so that prediction will be there, so that that intelligent decision about taking the downtime and clearing the coils or clearing the machineries, that can be done. Then with respect to if certain things that has happened, so if the site has certain different parameters which can provide the accurate information about the system, so that sometime we also take, because that is a challenge with many customers, that if you want to take certain temperature and pressure at certain sections, they don't have that. So we take certain proxy tags for that and try to simulate that particular information which we should have got from the original tags, and take that information from some other inputs. But again, as Simone said, it depends more on the actual problem, and we'll be happy to talk if you have certain kind of problem, so we can discuss more in detail later on that.
Thank you. Last question from Alex. Any models related to reliability of assets? So please go ahead, Simone. From I know you're developing models, we are developing models, so I'll make sure that we give the big answer here. Yeah.
Yeah, I mean, we have many, and depending, of course, on assets. But as I was mentioning before, we have both for like asset, like single asset categories. So, for example, for pumps, like centrifugal pumps, alternative pumps, for ESPs, we have for actuators, we have for heat exchangers, for different static and rotating equipment. And then we have also like bigger orchestrations where it comes to, for example, a whole FPSO or an oil rig, where actually there is several models from several OEMs that are running. So, for example, there would be a model from ABB, for example, there will be a model from Bentley Nevada, there will be a model from different vendors that actually all orchestrate and work together. But we have for many different kind of assets, we have done for pipelines, for oil producing assets, and in the chemical and petrochemicals, pulp and papers, and so on. So yes, we have many. We don't really believe that there is like an out of the box kind of model that you take for pumps and you click a button and it goes and works. So this is why we would love to know more and to go a little bit more in depth if you have some more specific questions that we can take maybe in a one-to-one later on.
Yeah.
Thank you, sir. Pradeep, any insights?
Yes, we have built certain models of these assets for the upstream companies, and for their fleet of compressors where they have the different vapor recovery sections. So any downtime with respect to that asset will lead to the twofold problem. One is equipment related issue, and other one is the loss of the valuable gas or valuable petroleum products. So we have built certain strategies for that, wherein we are predicting the failure mode also, and we are predicting the root cause, and proactively stating the condition of the asset, so that any action needed for that can be taken. So that prescriptive maintenance, I would say, that we are doing for certain this kind of equipments, and we'll be happy to walk you through the total model if you connect with us.
Thank you, Pradeep. My short answer for you is, Alex, that the way Tridiagonal has been in process optimization, process engineering work for a long time. Since that's our bread and butter business. So essentially, at the core, I would I can make a claim that we all asset optimization has been is being done in many industries. I can't cite all of them right now. In many of our customers, from pharma and oil and gas and chemical, we have essentially, as we see this as an optimization problem, meaning that predicting the problem upfront and essentially giving the solution to that, or prescriptive solution right there. And with the AI was our natural stepping stone, or AI was natural to us because we had been doing this modeling work, and LLM or Gen AI enabled interactivity with that. So it brought the user-friendly aspects to those models. Now, of course, we have to adjust our models a little bit so that it can interact with the queries, end user queries, in a variety of ways. But I'll conclude by saying that this optimization is at the heart of our business, and then Cognite's AI and data platform, definitely it makes our implementation processes much easier. With that, I will thank you for. Sorry, we're running over. That's why I begged for your forgiveness in advance. So hopefully, you will not think it was a waste of your time going over. Thank you so much. Mark, the email address is here, and you can find us on LinkedIn, our company, and all of these our great team here. So please reach out to us if you have any questions. Even though tomorrow, if you have any questions about what you saw, we are here to answer. With that, on behalf of Simone, Pradeep, Tridiagonal.ai, and Cognite, and personally, thank you so much for your time. We appreciate it. It's a lot to hear people talk for over an hour. Thank you. The recording will be there. You should be getting a link. So if you have any questions, let us know.
Thank you. Bye-bye.
Bye.
Thank you,
Thank you,
guys.
Simone. Bye.
Thank you,
Thank you,
everyone.
Pradeep. Bye.